Today we're going to do a complex circuit, and we are going to find V and I for the highlighted resistors. So the first thing we have to do is we have to analyze the circuit and simplify it down to where we can finally figure out RT and IT. Here is a parallel section. We can figure out what is the equivalent resistance for just this section. We can figure out what is the equivalent resistance for just this section and redraw. The only thing I want to point out on this one, we know that this 3, this 2 are all both in parallel with this whole branch. So to find this one in parallel, it would be 3 to the negative 1 plus 2 to the negative 1 plus 4 to the negative 1, because these guys are in series, so you can combine them. So I'm going to do that, and I have it right here. So what I did is I found out what the equivalent resistance for that first parallel section was, and then for this one, and then of course I wrote these because they're not in a parallel section. Now I can find from here the total resistance. So step number 1, like we always do, RT. So RT would be 0.92 plus 1.51 plus 3 plus 0.5. Because this is a parallel section, but it is in series with the other parallel section, is in series with these two. Turns out that the total resistance of the entire circuit is 5.57. Now for step number 2, we find total current. Total current is total voltage, and the voltage on the drawing was 24 volts over total resistance, and it turns out 4.31 amps flows through this circuit. Step number 3 is I draw it in. So I know how much current is going down there. I know how much current goes into this parallel section and how much current goes out. I'm going to fill that in. So I know it's 4.31 amps in and 4.31 amps out. How much current goes through these guys? 4.31. Gosh, I've already got their current. All right, so I'm supposed to find V and I for this, and there's one inside of here. So I can now find the voltage using Ohm's law for both of these. So I'm going to say voltage equals 4.31 times 3, and that the voltage drop across this guy is 12.93 volts. Same thing here. Voltage equals 4I times R, and the voltage drop across this guy, or the 0.5, I should have labeled this one, and the 3 ohm is 2.16 volts. Done. I've got their I's, I've got their R's, and their V's. There was one other thing we needed to do, and we needed to go back to this parallel section, and I needed to find his V and I. Okay, we determined that that whole parallel section, the equivalent resistance of this whole section, when we collapsed it and got one number, the equivalent resistance was 1.15. We also determined, because we know how much current is flowing around in this circuit, that the current in is 4.31 amps and the current out is 4.31 amps. All right, so if I know the total resistance and I know the total current going in, can I find the total voltage drop? I can. So I'm going to do it this way. I'm going to say the voltage drop for the parallel section, the whole section, is the current into the in and out of the whole section times the resistance of the whole section. And when I do that, I get a number of 4.95 volts. So I just determined that the voltage drop for the whole parallel section, V equals 4.95. I know its resistance, I know the current in and out of the whole section, so I know the voltage drop for the whole section. The beauty of knowing the voltage drop for the whole section is what's equal in a parallel section. If you know the total voltage drop for the whole section, you know that this is the same, this is the same, and this is the same. So back to the end, we want to know for the voltage drop for the 5 ohm resistor that's in the parallel section, P-A-R-A, okay, is 4.95. I know the resistance of that guy because it's 5 ohms. Now I need to find his current. Just the current down this branch. And you do realize that when 4.31 goes in, it's going to split. So we just need to find out how much current goes down his. Well, that's going to be easy. So I use Ohm's law. I am going to rearrange it, equals V over R. I equals, the voltage drop is 4.95 divided by 5, and the current is 0.99 amps. So I have got this guy's current, I have got his volts and his resistance. That's it.